So the essential question for today is how can you measure and classify an angle? So what are we going to be learning today? You're going to learn how to name angles, measure and classify angles, identify congruent angles, use the angle addition postulate to find angle measures, and we're also going to learn how to bisect angles. All right, so first question. A lighthouse keeper measures the angles formed by the lighthouse at point M. So here's a lighthouse, point M, and there are 3 boats. The 3 boats are J, K, and L. Name 3 angles shown in the diagram. So first angle we have JMK. So angle JMK. Or we could also say angle KMJ. The important thing is that this is your vertex, which is in the middle of your answer. All right. Next, we could also say angle KML or angle LMK. And then last but not least, there's one more angle. That's the big angle that we see here, angle JML or angle LMJ. All right, so the postulate 1.3 is the protractor postulate. So I'll let you guys read over this if you need to, but I believe most of you have used a protractor before. So let's see, there's different types of angles. I'm sure you've heard of these as well. There's an acute angle that measures greater than 0 and less than 90, and it looks like a tiny, cute little angle. A right angle measures exactly 90 degrees. It's usually going to be represented with this little box here to show you that it's a right angle and 90 degrees. An obtuse angle measures greater than 90 degrees, but it's less than 180 degrees. So the angle that would measure 180 degrees exactly is called a straight angle. It just looks like a straight line. All right, find the measure of each angle, then classify the angle as acute, right, obtuse, or straight. So the first one, we have angle GHK. So GHK. So I'm starting at 0 degrees and I'm traveling upwards. And because I know that this is bigger than 90 degrees, I'm going to look at the bigger number. So I'm going to look at the top this time. So that's 125 degrees. And I know it's a little hard to see on here. If you had an actual protractor, which we'll be using in class, then it'll be a little easier for you to see the exact numbers. But it's 125 degrees, and it is an obtuse angle. All right, the next one, angle JHL is 90 degrees. So you can see it's going from here to here to here. It's exactly 90 degrees, and it's a right angle. And then the last one, it's angle LHK. So this one's a little different. So where am I starting at? I'm starting at the 90-degree angle this time. On all the other ones, maybe you notice that we were starting at the 0-degree angle. Okay? So I'm starting at 90 degrees this time, and it's only open from here to here. So since this is obviously smaller than the 90-degree angle, this time I want to make sure that I look at the smaller number, not the bigger number on the top. Okay, so 90 minus 55, and take the absolute value of that, you're going to get 35 degrees. Okay, so if you look at this, does this look like a 35-degree angle? Hopefully it does to you. Hopefully you understand it's 35 degrees and not a huge number. So what kind of angle is this? It is called an acute angle. All right, next we're going to identify the congruent angles labeled in the quilt design. So you can see you have your angle arcs here. And so both of these have an angle, one angle arc only, as opposed to these ones which have 2 angle arcs. Okay, so first we have angle ABC, and that's going to be congruent to angle FGH. Remember, congruent means the same measurement. All right, and then we can also, now we're going to talk about the ones that have two angle arcs. So we can also say angle ADC is congruent to angle EFG. All right, the next question says, if the measure of angle ADC is 140 degrees right here, then we want to know what is the measure of angle EFG going to be. Well, because both of the angle arcs are the same, and we said that these are congruent, it's going to be the same, which is 140 degrees. All right, postulate 1.4 is called the angle addition postulate. So it's kind of similar to the segment addition postulate. Here I have a smaller angle, angle RSP in red, and then here I have another smaller angle, angle PST in green. If I add these two chunks together, that's going to give me the whole big angle, which is RST. So let's see an example of that in this problem. So given that the measure of angle LKN is 145 degrees, find LKM and the measure of angle MKN. So we're going to use the angle addition postulate. And as I said, angle LKN, that's the whole thing, is 145 degrees. So the angle addition postulate, LKN is equal to the measure of angle LKM plus the measure of angle MKN. So now I'm just going to plug in my information. 145 degrees equals, so that was the whole big angle. And now angle LKM is 2x plus 10. And then MKN, which is right here, and blue is 4x minus 3. So first thing I'm going to do is combine like terms. That's going to give me 145 equals 6x plus 7. So 2x plus 4x gave me the 6x. 10 minus 3 gave me the 7. Now I'm going to subtract 7 from both sides. That's going to give me 138 is equal to 6x. Now I'm going to divide both sides by 6, which gives me x equals 29. Right, but did that answer my question? No, because they want me to actually find the angle measurements. So now I'm going to plug in my information into my problem. So LKM was 2x plus 10. I know that x was 29, so I'm going to plug that in for x. I'm sorry, that should be 23. I don't know why I said 29. 23, my bad. So 2 times 23 plus 10. That's 46 plus 10, which is 56. And now I'm going to find MKN. So 4 times x minus 3. So 4 times 23 minus 3 is going to give you 89. When I add them together, 89 plus 56, I will get 145. So just as I said right here, to check it, just plug it in, add them together, and they should equal the same thing. All right, and then our last problem for today, it says ray QS bisects angle PQR, and the measure of angle PQS is equal to 24 degrees. Find the measure of angle PQR. Well, there's no picture here, right? So I'm going to have to draw my own. So first, draw a diagram. So I've got angle PQR, right? And then now I have ray QS bisects it. That means that QS is going to come out this way. And that means it cuts that angle in half, right? That's the word bisect. So here I have my ray QS. So now I can go ahead and fill in some more information. It says PQS is 24. I know that this one's going to be 24 also because it says it's bisects. And I'm about to run out of time. So I'm using the angle addition postulate.